Okay, welcome to Accelerated Math, mean and standard deviation. The two primary measures that we're going to use with statistics, mean and standard deviation. Alright, a lot of adults, they know about mean, it's just the average, but standard deviation, they kind of remember something about it, but oh boy, if you don't use it, it kind of falls away. Alright, all we're going to do, this first one is really simple. We're just going to take this data. I mean, you could hand calculate the average, but the standard deviation is kind of a pain to hand calculate. So we're going to go to list 1 of our calculator and enter it there. If you don't have one of these calculators at home, I wish I had it up here, but if you go Google standard deviation calculators, online standard deviation calculators, you'll find some things where you can enter a list of data and you can pick the population standard deviation, and that's what you would pick on this, is the population standard deviation. Alright, we're going to use the calculator here, and we pull it over on this side, clear everything out. I'm going to go to get to the data. I go to data, I hit data, and this is where the list feature is. If yours has numbers in it, you can hit data again and hit enter on clear list 1. So if there were some numbers in here like this when you first came up, and you just go, okay, hit data and clear 1. Hit data and clear 1 and hit enter. Okay, another way to do this is if you hit on clear. Well, I can't do it. I don't know how to do it here, but anyway, because I can't hit two keys at the same time. But if you hold down on and hit clear, it will clear it out. But anyway, so I got the clear list, and 3, 4, 10, 12, and 16. Enter. I've listed my data. I've got 5 data points. You can see it's on number 6 here for this, but that's in the next blank spot. To get that data out, like to see, I'm going to show my history here so you can kind of see what I've been doing. Okay, so I'm going to go to second stat, pull that up just a notch, second stat, and look at one variable statistics. I hit enter, and I'm using list 1, and the frequency is 1. That's kind of the defaults unless I enter the frequency in there. I hit enter there, and it goes to calculate, and I get a list of one variable statistics. And the first thing is the number of values in it. The next thing is the mean, so I know the mean is 9. And then I've got this S sub x, that's the sample standard deviation. That's not the one we want. We want number 4 because this was not a sample statistics that we were doing. This is the entire population, and it's 4.89. So I had a mean of 9 and population standard deviation, or sigma x, that's that symbol, 4.89, probably 4.9 on this thing, so 4.9. So they were asking for the standard deviation, and it came out to 4.9. You can see, did they include? No, they didn't even include that sample standard deviation. Okay, well, anyway, simple enough on that one. Now, here's where it gets a little bit more difficult. The scores for a standardized reading test are found to be normally distributed. Now, the key word here is normally distributed. As soon as you see normally distributed, you know that the data follows this nice little bell curve, and that the mean is basically going to be in the middle. In fact, they give us a mean, and then we're going to look at standard deviations, 1 standard deviation away from the mean, 2 standard deviations away from the mean, and 3 standard deviations away. Also, 1 going this direction, 2 going this direction, and 3 standard deviations away from the mean. So the mean, or the average value here, was 400. So standardized test scores where the average person got a 400, and everything else was normally distributed around this with a standard deviation of 44. That means that this 1 standard deviation out would be 400 plus 44, and the next one would be 444 plus another 44, so that's 488, and then finally another one that would be 2 and, whoa, well, yeah, you try to do this in front of people. Alright, 532, I think. Yeah, that looks right. Alright, and then going the opposite direction, this is going down, so I'm subtracting 44, and so I'd have 356, 312, yeah, I'm getting this right, and 312 minus 44, minus 44, sorry, gotta pull back a little bit, 8, and 30 minus that is 268. Okay. I think that's right. All right. Well, anyway, so those are the values, and they're asking how many students are expected to have scores between 400 and 488. So they're looking for this space right here. How many students would fall in those first two categories? Now, the key numbers that you need to be aware of are, well, you know what? 68% of the scores in a normally distributed thing like this are going to fall in the first two. This is one standard deviation away and one standard deviation this way, 68%. So the magic number is, well, 34% is there and 34% is there. 90, let's see, what is it, 95, whoa, wait a second, 97, 99.7 and 95%, it's generally accepted, are going to fall within these first two standard deviations. And if you kind of split the numbers up, you find out that 13.5% is in here, 13.5%. If you're wondering where that came from, I did 95 minus the 68. That left me with what was in those little two segments over there. I don't want to confuse you too much about this, but and then I took that 27 that was left over there from that and divided by 2. And that's where I got my 13.5 that falls into each one of these categories. Don't get too concerned about that. Know these numbers, 34, 34, 13.5, 13.5, and 2.35, because 99.7% of the data is going to fall within those first three standard deviations. And so what they're saying is virtually all the data is going to fall within 100%, almost all of it's going to fall within three standard deviations of the mean. Now, we were only concerned with these two that are shaded in. If you add those two, you get 47.5%. So 47.5% of the students should fall in there. And if you multiply 47.5% times 500 with the calculator, if you have that, if not, you can do 47.5 out of 100 equals x over 500, and then you can cross multiply that, so you get 100x equals whatever 47.5 is, 47.5 times 400, and then you divide both sides by 100. Now I'm going to pull up the calculator and do it with this. I'm going to turn off that, give myself a little room. Alright, so we're just doing 47.5% second% times the 500 students, and we get 237.5. Can't have half of a student. We're going to round up naturally, so, or in this case, so 238. I want you to notice that 238 is not there. The closest thing is 239. The main reason for that is because while we teach 34%, it's 34 point something percent is the official thing. So we're going with that. All right. And then, of course, I was talking about this other way, 47.5 times 500 equals 27, and then divide that by 100, which just kills off two of the zeros, so 23.7. Whoa, I did by 1,000. 237.5. Alright, so we get the same answer. So you got to know the bell curve thing. You got to know those percentages in there to be successful with this. Alright, last one. I want you to ignore all this stuff over here for a while. And let's get this bell curve. And same thing we did a minute ago, the mean of 166. And they're talking about a standard deviation of 20. Alright, so 186, 206. They made my math a little bit easier on this. I'm going by 20s. Alright, 146, one standard deviation, two standard deviations, 126, and three standard deviations, 106. Alright, let's see what they're looking for. Number of absentees at this elementary school believed to be approximately normal distribution with a mean of 166 absentees per day. Wow, man, they got to get these kids to school. Alright, and a standard deviation of 20 absentees per day. Use the table below, blah, blah, blah. They want to find out fewer than 126. So if you go to 126 over here, and if you shade that in, now you remember a little while ago, we talked about these numbers, 34, 34, I told you you need to know these, 13.5, 13.5, and 2. I just said you need to know them, and I'm not sure I know them. 2.35. Hey, is that right? 2.35 all of a sudden? Yeah, I think that's right. All right, so 2.35. And so that's the percent of students that should be in there. And I told you to kind of ignore that over there for a minute. So the answer on these things, I've noticed in multiple choice, they're in probabilities, and that's a percentage. And to go from a percentage to a decimal, you just move over the decimal 2 places, so it's 0.0235. And I think that that was one of the answers on there. So we're just taking that decimal, moving it over twice. Now, you may be looking at your problems and saying, whoa, they didn't give me that nice little cutoff at a certain standard deviation. What they did was they found some middle point here and said, what's the chance of it being higher than a certain number or something? And they said 196. And you're going, well, that's sitting in the middle there. And so what I'm trying to find now is I'm trying to find everything that's over here. Should I just take half of the 13.5? No. Watch this. We're at 1 standard deviation, 1.5 standard deviations. This is where the table comes into play. So at 1.5 standard deviations away, they're showing me what they call it the probability of it falling in between there. It's 40. I'm going to change that to a percentage. 43.3% of the students are going to fall in there, or the chance that it's going to happen is going to fall in there. So watch this. If at the mean, what's the chance that it's going to be to the right of the mean? Well, that's 50%. You can kind of see that. That's half of it. Well, if 43.3% is over here, then you just have to do a little subtraction and get 6.7% over here, or 0.067, and that's where you're going to find your answer for that. So you just kind of have to figure out where it is. You might find things that are 1.5 away from the standard, from the mean. You might find 2.25, 2.75, and just do a little subtraction, and you should be good with that. All right, that's it for today. We'll see you on the next one.